Okay, selamat petang semua. Tak ramai masuk, tak apa. Saya record je untuk video ni. Kalau ada soalan, you all boleh just buka mic tu, boleh tanya terus. Ataupun boleh write dalam kat chat pun boleh. Okay je. Okay. Okay, kita guna notes. Topik today ialah chapter 6. Chapter 6 about nuclear physics. Okay, nuclear physics. Okay, ada yang masuk. You all boleh buka mic tau, nanti bosan kan, boleh cakap-cakap. Boleh tanya-tanya soalan. Okay, untuk topik nuclear physics, chapter 6, the first part is about radioactive decay. Explain with example decay equation. Kita ada alpha decay, beta decay, gamma decay. Okay, explain half-life through example. Determine half-life of radioactive sources from decay curve. Solve problem involving half-life. So ada calculation dalam bahagian ni. And then 6.2 ialah about nuclear energy. We will discuss about nuclear fission and nuclear fusion. Describe relationship between energy release during nuclear reaction and mass defect. Guna Einstein formula, E equals to mc squared. And then solve problem involving nuclear energy due to radioactive decay and nuclear reaction. Okay, and then describe generation of electrical energy in nuclear reactor. Justify the use of nuclear energy as alternative energy to generate electrical energy. Not included in this module. Dia tak ada dalam modul ni, tapi boleh baca dalam buku teks. Okay, saya akan tunjuk sikit nanti. Okay, let's start. Let's start. Dia takut saya tak nampak. You all punya, tak apa. Saya letak di tepi. Okay, kita start. Okay, first part. Before I continue, let's recall what you have studied in lower form. You all dah belajar structure of nucleus of an atom, which is consists of either proton, neutron, and of course electron. Okay, so at the center, nucleus. Okay, nucleus, and then surrounding in orbit is electron. Okay, and then for element of atom, normally we denote as X, A, Z. Okay, ini simbol untuk atoms atau element. For example, carbon, carbon 612. Okay, so we can see the A here represent nuclear number. Nuclear number equals to proton plus neutron. And then Z here is proton number. So if we look at this carbon 6, the proton number Z equals to what? Sorry, saya terbalik. 12, 6, sorry. Carbon 12, carbon 12. Carbon 12, 6. Okay, Z ialah 6. A equals to 12. Means proton equals to 6. Proton plus neutron equals to 12. Thus, neutron equals to 6. Okay, boleh nampak tak dia punya tu? Okay, this is nuclide notation. Okay, later we will use this symbol to represent atoms. Okay. Next, radioactive decay. Kalau ada soalan, you tanya terus tau. Mungkin saya akan laju dan terus tak stop, tunggu you all. You all boleh buka mic dan terus tanya je. Okay, 6 radioactive decay. So topik ni we discuss on the radioactive substance. Okay, radioactive. Apa maksud radioactive? dia sangat aktif lah maksudnya kan. It is unstable nucleus. Kita mention about radioactive substance means unstable nucleus. So whenever it is not stable, tendency to become stable will cause it to emit radioactive radiation. Means we have this process known as radioactive decay. Process in which unstable nucleus become more stable by emitting radioactive radiation. Okay, when we talk about radioactive radiation, it can be very energetic particle like alpha and beta, and also in form of electromagnetic wave or energy, gamma. Okay, radioactive decay is random and spontaneous. Means we cannot detect when it will happen and which atom will decay first because it is unpredictable. That's why we call it random and spontaneous. Okay, kita tak tahu mana satu akan decay. Okay, dan bila akan berlaku juga kita tak tahu. So that's why we call it random spontaneous. Not influenced by factors like temperature, pressure or other physical factors. Okay, tak ada faktor yang mempengaruhi dia. Okay. Ini contoh unstable nucleus release energetic particle like alpha, beta or electromagnetic wave or energy like gamma, so it become more stable. So the process we call it radioactive decay. Okay, so you need to memorize the definition of radioactive decay. Okay, because of we have 3 different type of radiation here, alpha, beta, gamma. So we have 3 types of decay process. If the process release alpha, we call it alpha decay. If the process release beta, we call it beta decay. If the process release gamma, we call it gamma decay. Okay, before that, let's look at what is alpha actually. Okay, what is beta? What is gamma? Okay, alpha, okay, actually is nucleus of helium. Helium you tahu kan, dalam periodic table you boleh tengok di mana helium. Nucleus of helium, and nuclide notation is 42He. Ini simbol dia alpha. Okay, beta. Beta tu apa? Okay, kalau beta ialah electrons. Okay, beta actually is electrons. Okay, saya nak tulis ni sebab ada gangguan, saya padam dulu Okay, beta ialah elektron. Okay, apa nuclide notation untuk elektron? E0 -1. Okay, gamma, ada tak nuclide notation for gamma? Okay, ada nuclide notation tak untuk gamma? Yes or no? Is there any nuclide notation for gamma? Anyone? No, yes, because it is not a particle. Dia bukan particle. Dia tak ada proton, tak ada neutron dan sebagainya. Tak ada mass. So hanya alpha dengan beta saja ada. Okay, so you must know this one. Nuclide notation you must understand. Okay, so gamma tak ada. No nuclide notation. No mass. Okay, notation. Okay. Okay, we look at the first one, alpha decay. Okay, an unstable nucleus releases alpha particle to become more stable nucleus of a new element. Okay, ini secara general, like say unstable nucleus ialah element X, element XAZ. Let's say I give you one example lah for this one. For example, based on the textbook, you can look at polonium. Okay, polonium example. Example, kita ada polonium 210 84. This is not stable, so it will undergo decay process, become plumbum. 682. Okay, plus 1 alpha. Okay, so the polonium release 1 alpha to become new element which is more stable. So this process we call it alpha decay. Okay, because release out alpha. Okay, so when you want to explain this alpha decay, you can just write general equation. If you are able to memorize one example, so you can do it if you can. If not, you just use the general one. So you will look carefully the proton number. Okay, the nuclear number first. Nuclear number 210 become 206, meaning sudah hilang 4, the nuclear number. Okay, and then the proton number 84 become 82. Okay, lost 2. So means general equation here, you can see the new element has the nuclear number which is less 4 than the original one. And then the proton also less 2 from the original. Okay, and then this one is alpha. So boleh tulis yang general ni untuk explain. Okay, kalau dapat hafalkan, okay lah, boleh hafalkan. Okay, okay, itu ialah alpha decay. Okay, let's look at beta decay. Ini beta decay. Okay, unstable nucleus, okay, decay to become more stable by emitting 1 electron atau beta. Okay, nuclide notation 0, -1, E. Okay, so this is example of decay process. We can look at one example. Let's say natrium, natrium, example, natrium 2411, okay, become magnesium, magnesium 2412, release 1 beta. Okay, we look at the nuclear number, no change, okay, in nuclear number, but you can see the proton number increased by 1, okay, for the new element. That's why here you can see A, new element, also same nuclear number, and then the proton number increased by 1, okay, and then this one is 1 beta, okay. Actually, if you want to check both sides, the nuclear number must be balanced. Okay, the left side before and after should be equal, nuclear number. And then the proton number also before and after should be equal. Itu example untuk beta decay. We look at gamma decay. Gamma decay, unstable nucleus releases excess energy. Unstable because the energy is too high, like excited electron at high energy level. So tendency to go to the higher level to become stable, for example lah, or going to the lower level, release out energy also can. Okay, this is nucleus excited state. Undergo decay process, release energy. The energy released in the form of gamma ray. So it become less energy nucleus. So unstable become more stable by emitting energy. Okay. If you look at the nuclear number, no change in nuclear number, no change in proton number. It's still the same element, but different in energy. Okay, so this is 1 gamma release. Cannot say 1 lah, actually it's gamma. Okay, gamma release or energy release. Example, we have cobalt. Cobalt 6027. Okay, which is high energy, high energy. High energy, so it is not stable. Okay, release some of energy, become still cobalt, cobalt 6027, low energy, plus gamma. Okay, ini adalah example untuk gamma decay. Okay, ada soalan tanya Okay, we go to next one. Okay, radioactive decay sometimes not just release one particle ataupun one type of radiation. Example, uranium-234. Okay, uranium-234, okay, decay to become thorium-230. You can see here release alpha and gamma at the same time. So it emits, sometimes emits more than one. Okay, uranium-234 92 become 230 90 thorium. Okay, so how we can, if you check carefully, you can balance the nuclear number left and right and proton number left and right. Ini example. Okay, we look at the question. Cuba kita jawab soalan ni. Fill the empty spaces with suitable answers. Okay, we have thorium 230 90. Okay, emit 1 alpha to become radium. Okay, so if you look the new number, the new nuclear number and proton number, we can just balance, or you want to use the mathematical equation also can. Let's put A and Z for radium. Okay, we can check the nuclear number. For the left side, 230 must be equals to A plus 4. A plus 4. Thus A equals to 226. Okay, and then for Z, okay, 90 equals Z plus 2. Thus Z is 90 minus 2, 88. So what we get here? 226, 88. Itu secara mathematics lah. Tapi just by look at the value also, you can get the answer. Balance kan, left and right, the nuclear number and proton number. Kejap loading. Okay, you all can try yang 8 soalan tu. Saya bagi masa 5 minit cepat. Okay, kita cuba number 2. Number 2, answer dia apa? Fujin Yi. Apa answer? Number 2. Ramai pergi tuition petang lah. $59.26. Okay. 59.26. Alright. Okay, good. Balance. Okay. Left, right. Number 3. Number 3. Ling ZG. Ada. 23491. 23491. Correct. Number 4. Number 4. Siapa nak try? Joseph. Joseph. Gamma. Okay, nampak tak? No change in nuclear number and proton number. So sini ialah gamma. Okay, so you do all you can do, just do like that. Okay, we look at number 5. Number 5 apa answer? Wang Sun Jian. Number 5, E. Okay, ini ialah electron atau beta lah. Okay, sebab no change in nuclear number, proton number increase by 1. Okay, so the rest I think you can try. Okay, number 6 tu polonium. Polonium. Saya kena laju sikit lah sebabnya nanti tak sempat habis. Ini 21084. Okay, here you nampak dia punya nuclear number reduced by 4. Maksudnya ini adalah alpha, 42He, nucleus of helium. And then cobalt ini ialah unstable because of high energy, release gamma. So, nuclear number, proton number masih sama. Okay, that one is for the process of decay, alpha, beta, gamma. Okay, now we look at the decay series. Okay. So this graph actually can show the decay series where y-axis is nuclear number, okay, x-axis is proton number. Okay, so from the decay series, we can check how many alpha, how many beta release out. Okay, what is it gamma that release out? For example, P to R ataupun R to V, how many alpha? Okay, so this is a decay series. Start from P become Q, Q become R, R become S, and then U, and then V. Okay, how to read the nuclide notation? You just can read from the graph. For example, P, P. Okay, baca je di sini. Okay, so dia punya nuclide notation macam mana nak tulis? Okay, maksudnya P, dia punya nuclide notation ialah 14233. Okay, so kita boleh baca terus daripada decay series atau daripada graph ini. So this graph showing decay series. Okay, means starting from the phosphorus. Okay, not phosphorus, it's P, and then become Q, and then become R. Okay, boleh continue lagi selagi dia tak stable. So we can check the number of alpha, beta, gamma release out. Okay, let's look at the example. Based on the decay series above, calculate how many alpha and beta decays between nucleus P and V. Okay, kita start dari P sampai V. How many alpha? How many beta? Okay, satu cara ialah we can just look at one by one. Also can. For example, P become Q. Okay, no change in nuclear number. Proton number increase by 1. Okay, increase by 1. So we can also do from here. I show you one step. So you can check from here. So this is 1 beta release out. And then from Q to become R. 142 become 138. Dia punya nuclide dia minus 4 nuclear number. And then dia punya proton number 34 become 32. Also minus 2, meaning 1 alpha release here. And then R138 become 134, also reduce negative 4 or reduce 4 for nuclear number. And then the proton number also reduce 2. So means here also 1 alpha. Okay. And then S to T, no change in nuclear number. The proton number increase by 1. So ini ialah beta. T to U, no change in nuclear number. Proton number increase by 1. So beta. Okay. And then U to V, okay. You can see the nuclear number reduced by 4. Proton number reduced by 2 alpha. So from here, it released how many alpha? 1, 2, 3. And then how many beta? 1, 2, 3, 3, 3. Okay. Maksudnya sini ialah tadi beta. alpha, alpha, beta, beta, alpha, beta, beta, alpha. Okay, another way. Do you have any other methods to solve this? By mathematical method. For example, P, we know it nuclide notation is 14233. Okay, P, 14233. So it become V. V is 13030. 13030. Okay. We don't know how many alpha release out, so I just take X. I just put X for 2HE. And I don't know how many beta, so I just put Y. So by using mathematical problem or operation, use the nuclear number. 142 equals 130 plus 4x. Y times 0, 0. So from here we get 4x equals to 12. Thus, x equals to 3. Means automatic we get 3 alpha. Now we use the proton number. 33 equals to 30 plus 2x minus y. Okay, x already get here is 3, means y equals 33 minus 30 minus 6. Okay, is it correct? Wait, y here. 30 plus 6, 36, 36 minus 33. We also get 3. Means there are how many alpha? 3 alpha and 3 beta. So this is also can be used to find the answer. Okay, kalau you nak guna mana-mana pun boleh, up to you. So sometimes mathematics will help us to solve the problem faster. Okay, up to you. Sometimes come out in paper 1, so you boleh guna teknik itu. Any question? Boleh tanya. Saya teruskan. Okay, let's look at characteristic of alpha, beta, and gamma. I think you have studied in lower form about the property of alpha, beta, and gamma. Alpha, as we know, is nucleus of helium. When we talk about nucleus is positive. Okay, so the charge is positive. Beta is electron, so of course it is negative. Gamma is electromagnetic wave, so it is neutral. Okay, we talk about penetrating power, ability to pass through any medium. Okay, for alpha, penetrating power is the lowest. It can be stopped by a piece of paper. Okay, piece of paper. Okay, we have alpha, beta, gamma. Let's say we have piece of paper. Okay, a few cm of aluminium, a few cm of lead. Okay, if we let alpha to pass through, alpha just can travel and stop here. This is a piece of paper. Beta can pass through paper and stop by aluminium, a few cm of aluminium. Gamma can pass through paper, can pass through aluminium, can be stopped by lead or concrete. Okay, so this one shows the penetrating power. Kuasa menembusi suatu medium. Okay, penetrating power. Alpha, very low. Okay, beta, medium. Okay, gamma, high. Okay, ionizing power. What is this ionizing power? Okay, when travel in air, ability to produce positive ion and negative ions. Okay, for alpha, alpha is a very large nucleus, 42He. We look at the nuclear number as compared to beta. Okay, we look if object is large, travel in air, possibility to hit the air molecule is higher, larger mass. So means when collide with air molecule, it will cause the electrons maybe kick out and produce positive ions and negative ions. So for alpha, ability to produce that ions is high due to larger mass. For beta, medium, because it still has mass, smaller mass. For electromagnetic wave or gamma, low, or we can say ionizing power nearly zero, not able to ionize the air molecule. Okay, itu ialah karakteristik of alpha, beta, gamma. Okay, ada soalan you tanya saya terus je buka mic, boleh buka mic. Okay, exercise. Okay, sketch appropriate lines in the diagram below to show direction of particle or ray in electric field. Okay, explanation for A. Okay, so you can see this is electric field, means this plate is connected to a positive terminal and this plate is connected to negative terminal. Okay, so there are potential difference or electric field, okay, between the two plates. Okay, when alpha, beta and gamma, if you let alpha, beta and gamma to pass through, okay, the electric field, for alpha, alpha is positively charged. So it will be attracted to positive. Negative, alpha silap cikgu ini negative. So alpha positive, so deflected to negative. Okay, for beta, beta is lighter, so deflection is more towards, okay, towards positive plate. How about gamma? Gamma, no charge. No charge, it will continue without deflection. Okay, ini yang berlaku. Okay, explanation for alpha. Alpha is positively charged. Okay, positively charged. Thus, it will attracted to negative plate. Okay. For beta, samalah cara penerangannya. Beta is negatively charged. So attracted, tertarik ke positive plate. Okay. Untuk gamma, gamma is neutral. So does not deflected by electric field. Okay. Okay, jadi dia tak ada deflection. Okay. Okay, ada soalan? Jangan tidur saya cakap sorang-sorang, lepas tu you tidur. Okay? Okay? Until now, is it okay? Buka lah suara, nak dengar suara. Okay, we go to next, number 2. Arrange alpha, beta and gamma. Okay, this one I have discussed just now already. Okay, so we can just state, okay, alpha, beta, gamma. So what is X, Y? X ialah paper. Okay, Y ialah aluminium. A few cm of aluminium. And then this one is lead atau concrete lah. Okay. Okay. Okay, number 3, sources of alpha particle not suitable to be used as tracer in medical industry. Faham tak maksud tracer tu apa? Pengesan, tracer. Based on your understanding of alpha's ionizing and penetrating power, explain the reason. Kenapa alpha tak boleh guna? Tracer biasa kita guna ialah gamma. Contoh dalam bidang medical, dia guna untuk trace cancer cell ataupun blood clots pun boleh. Contohnya you ada injury, maybe ada ketulan darah dekat mana-mana dalam badan. So doktor boleh guna teknik ni guna tracer. Okay, dia akan bagi you minum dalam suitable amount untuk radioactive substance tu yang release out gamma. Okay, jadi gamma tu dia akan masuk dan dia akan guna gamma camera, dia boleh detect your body parts di mana ada cancer cell. Okay, itu ialah tapi untuk alpha ni property dia ialah very high ionizing power. Faham tak maksud ionizing? Kalau dia masuk dalam badan you, dia collide dengan you punya sel-sel, dia boleh ionizekan. Bila dia boleh ionize, it's very dangerous sebab dia boleh create new element dalam you punya badan. Tissue, maksudnya bukan element, dia create new tissue. Bila ada new tissue, maybe dia boleh cause the growth of new cell that is cancer. Jadi actually alpha is very dangerous. So ini satu benefit sebab this can be stopped by a piece of paper. Okay, kalau you pakai baju pun dia tak boleh masuk. Dia can be stopped by a piece of paper. So itu ada dari segi benefit kepada manusia lah. Okay, kita biasa pakai gamma. Gamma very high penetrating power and low ionizing power. Dia bagus. Okay, dia boleh kill the cell but not ionize. Itu beza dia. Jadi ni boleh explain lah dari segi ni ialah very high. Alpha has very high ionizing power. Ionizing boleh ionizing power. So it can harm the cell. Okay, boleh macam tu. And then also alpha has low penetrating power. Okay. So memang dia tak boleh pergi ke tempat-tempat yang terselindung pun. Yes, ada apa tu? Ada saya check. Ada siapa nak masuk ke? Cuba request sekali lagi. Siapa tadi? Ada yang nak masuk ke? Tak ada. Okay, low penetrating power so cannot be detected by detector. Kalau you ambil, you consume, doktor bagi, radioactive substance that emit alpha. Tapi alpha tu dia tak boleh keluar sebab dia dah stop by you punya tisu dalam pun sudah stop kan, dia punya bagaimana pergerakan untuk alpha tu. So cannot be detected. Itu juga satu sebab. Kalau pakai kamera to detector. Ada soalan tanya? Okay. Now we go to next part. Tak ada soalan, saya terus Okay, half-life. Why we need to just to study about half-life ni? Apa importance yang you tahu tentang half-life? Okay. Kalau the use of radioactive substance dalam medical, it's very important for you to know whether the radioactive substance can stay longer in your body or not, because it cannot stay longer. Normally untuk tracer tadi, kalau radioactive substance, dia tak boleh lebih daripada 6 atau 8 jam. Cannot be more than that. So certain amount of the radioactive substance, it cannot stay longer in your body. It's very dangerous. That's why we need to know the half-life. Perlu tahu half-life dia. Okay? Contoh, if you put inside is 1 gram. After 8 hours, how many left? Is it still cause dangerous to your cell or not? Okay, itu maksudnya. So you must know the half-life. Okay, so what is half-life? Half-life, the main key point ialah time taken. Ramai yang suka salah bagi. Okay, ramai yang tulis mass become half. No, it is time taken. Okay, half-life is time taken for sample of radioactive nuclei to decay to half of its initial number. This initial number can sometimes measured in mass ataupun activity, because it very hard to determine mass, because radioactive substance is very unpredictable. Okay, the process of decay maybe keep going on, so you cannot say the mass is fixed at 1 gram at one time. Okay, sometimes we use activity per second. Maksudnya activity per unit time. We just can record this. Okay, sebab tu dia guna dua. Sama ada guna mass ataupun activity per second, activity per hour. Okay, something like that. Okay, let's look at here. Okay, example. Let's say this is a nucleus of radioactive nuclei. Okay, initially 16. Okay, after one half-life. Half-life, we use the symbol T half. Saya guna symbol T half. After one half-life, okay, the activity or the nucleus become half. 16 become 8. Okay. After another half-life, okay, become half from before, so 4. After another half-life, become 2. After another half-life, become 1. So you can see 16 to become 1. Okay, the time taken is how many half-life? 4 half-life. Okay, so the time needed for the amount to become 8 is 1 hour. So 1 hour is half-life. Let's say kalau ini adalah 1 hour, means here is 1 hour, here also 1 hour, here also 1 hour. Okay, so time taken for the nucleus to become half from its initial number. Okay, half-life of material is constant. For example, half-life of uranium, half-life of radium, half-life of polonium, they are all constant. Okay, example. Okay, a radioactive material has half-life of 20 days. Calculate number of days taken for the activity of sample of radioactive material to reduce to 12.5% of its initial activity. Okay, ada cara kita boleh guna teknik ni. You all boleh lukis lah. Kalau dia guna persen, initially ialah 100%. Ini initial lah. Initial kita guna simbol NO. NO. Okay, after one half-life, okay, it will become 50%. Okay, after another one half-life, it will become 25%. Another half-life, it will become 12.5%. So means the half-life is 20 days. Maksudnya ini 20 days, 20 days, 20 days. Okay. So what is the number of days taken? Means 20 plus 20 plus 20. So the number of days or the time taken ialah 3 half-life. Means 3 times 20. So we get ialah 60 days. Ini satu cara. Boleh guna cara ini, tak ada masalah. Okay. Another method is using formula. Okay, kita nak tunjuk cara guna formula. Okay, sebab sometimes some of the question cannot be solved by using this drawing. Ada yang kena guna mathematics, like using log dan sebagainya. Ada soalan yang guna log. Okay. Jadi kita tengok sekejap contoh soalan. Bagaimana dapat formula ini? Okay, I will show you how we get that formula. Okay, kalau ada soalan cepat-cepat tanya. Saya kena memang laju dah dekat pukul 6 dah Okay, untuk half-life tadi, let's say the NO initial number ialah 100%. Okay, 100%. Ataupun very simple saya letak 1 pun boleh lah, 1 pun boleh, tak apa. Okay. Okay, ini Yang dalam kotak ni, yang saya tulis ni, 50, 25, 12.5. Ni apa ni sebenarnya? Nanti you confuse pula saya cakap. Ini yang not yet decay, belum decay. Okay, yang tinggal tu yang belum decay. Okay, yang belum decay yang dah decay tu tak boleh buat apa dah, dah hilang dah. Okay, so in the box here, all the not yet decay. So I will just discuss about the not yet decay. Yang dah decay tak tahulah mana dah pergi. Okay. Okay, let's try to check the fraction left. Macam mana kita nak kira fraction left? Let's say the fraction, the n after 1 half-life ialah 50%. Berapa fraction left dia? Ialah n divided by NO. Meaning 50 over 100, which is 1 over 2. Okay. So ini dia ambil berapa half-life? 1 half-life. Okay, saya buat table. Okay. Number of half-life n. Ini fraction left. Okay. Kalau N1, satu half-life, kita dah tunjuk ialah 1 over 2. Kalau 2 half-life, dia apa? Another 1 half-life. Dia akan jadi 25. Okay? 25 over 100 ialah apa? 1 over 4. So ini akan jadi 1 over 4. Maksudnya half from before, half from before. Ini ialah 1 over 2 to the power 2. Okay. Kalau 3 half-life, okay, boleh continue lagi. 3 half-life, okay, continue lagi. Ini ialah 12.5. Okay. 12.5 divided by 100 ialah 1 over 8. Half from before, 1 over 8. Okay, is half to the power 3. If we have 4 half-life, half from this one is 1 over 16. So it's 1 over 2 power 4. Okay, this is half, means half to the power 1. Can you see the pattern or not? 1 half-life, the fraction left is half to the power 1. 2 half-life, half to the power 2. 3 half-life, half to the power 3. 4 half-life, half to the power 4. So means after n half-life, what is fraction left? Half to the power n. Okay, thus we can calculate what is the amount of nucleus ataupun activity left, n. After n half-life is the fraction left power n multiply initial activity. That's the reason why we get that. Kita dapat itulah. Ini ialah untuk n half-life. Okay, n half-life. Boleh tak? Okay, saya tunjuk cara dapat formula je ya. Okay, now we go to the notes balik. Sini. Inilah datangnya formula tu. Let's say saya nak guna teknik ni untuk jawab soalan tadi. Saya tak mau lukis. You boleh lukis, tak ada masalah. Boleh. Tapi ada yang tak boleh lukis panjang sangat sampai 20 half-life. Takkanlah you nak buat panjang sampai 20 kan. Okay. So N 12.5. NO 100. What is N? So 12.5 equals half to the power n 100 means half to the power n equals to 12.5 divided by 100, which is equals to 1 over 8. 1 over 8 is half to the power 3. That's the reason why we get n equals to 3. Okay, once you get n equal to 3, so the time taken is 3 half-life. Okay, 3 half-life. Okay, which is 60 days. Okay, itu penggunaan formula. Okay, penggunaan formula. Okay, kalau guna formula, inilah formula dia. Ini yang without. Ini without tadi saya dah tunjukkan dah. Sama je tadi. Okay, ini guna without formula. Jadi you pun lukislah sampailah. Kalau 10 kali pun you lukislah panjang-panjang. Okay, up to you lah. Okay. Sometimes some question is not easy to solve by drawing like this. Easy solve by using formula. Ada soalan? Any question? Senyap lah. No, okay. Terus lagi, sambung. Okay, half-life continue. Okay, now decay curve. Okay, as I mentioned just now, the decay process is random and spontaneous, unpredictable. Okay, so the amount of activity reduced with half-life actually is exponent graph. Bentuk curve macam ni, exponent. Okay, sebab dia is unpredictable and random, tak boleh tahu bila. So dia macam kita boleh guna teknik probability to get this decay curve. Okay, tengok ini panggil decay curve. Kita ada y-axis ialah activity. The x-axis is time, sometimes given in minute, second, hour, years. Ikutlah mana. Okay. The graph you can look at here, ini yang bila time 0 tu ialah NO. Ini ialah NO. Initial activity, NO. Okay. Okay, you can look at here, NO 300 reduced to half, meaning 150. What is the time taken? You can read from here, 12. Okay, untuk yang green color, green color 12. So ini ialah half-life for A. Okay, half-life for A. Kita dapat ialah 12 minit. Okay, untuk B, okay, baca graf B. Turun sini. 8 minit. So half-life for A, 12 minit. Half-life for B, 8 minit. Terus boleh dapat dari decay curve. Okay, soalan tanya. What is half-life of A? 12 minutes. Jadi kena lihatlah ini dia punya initial activity become half. Divide 2. Baca berapa minit. Itu half-life. Okay. Half-life of B, 8 minit. Compare decay rate A and B. Okay. B decays faster than A. So rate of decay for B is higher than A. Tengok je half-life dia. Okay. Rate adalah tinggi kalau half-life ialah shorter. Okay. Dia cepat lah, cepat habis lah. Dia punya aktiviti tu cepat reduce lah. Sebab dia short half-life. Okay. Masa diambil lebih pendek. Sebab itu kita panggil rate of decay B is higher than A. Okay. Example. Okay, exercise number 1. Sample of radioactive material has initial activity 200. If its half-life is 20 minutes, how much is its activity after an hour? Okay, let's try one question. Initial activity, NO. Okay, 200, second -1. Half-life, 20 minutes. Okay, how much activity in 1 hour? 1 hour is 60 minutes. So what you do, you need to find number of half-life N. Macam mana you kira number of half-life? You just take time taken divide by half-life. So mean 60 divide by 20 ialah 3 half-life. So how much activity after an hour? Means you nak cari N. Kalau saya guna formula, saya just guna macam ni saja. Half to the power 3 times 200. 200 divided by 8. Okay, I will get 25 second -1. Ini guna formula guna formula. Kalau you tak nak guna formula, you boleh lukis, tak ada masalah. Okay, 200, okay, reducekan sampai, ini 20 minutes kan, 20, okay. Okay, dia jadi 100, another 20, dia jadi 50, okay, another 20, dia jadi 25, okay, we get the answer. Okay, 25. Itu guna teknik without formula. Yang first tu lebih senang lah banding formula kan. Kalau you tak biasa guna formula, you rasa susah. Tapi actually, I think formula is quite easy for you all to know. But you need to memorize, not given. Ini tak ada dalam list formula ni. Untuk yang formula ni tak ada dalam list. You need to memorize kalau you nak guna. Okay. Okay, try question number 2, 3, 4. 5. 2, 3, 4, 5. Okay, dalam masa 3 minit. Laju-laju. Ada soalan? Siapa nak try? Boleh angkat tangan. Soalan 1 nak bagi jawapan. Number 2, apa jawapan dia? Siapa nak try? Angkat tangan. Ataupun saya nak panggil nama yang belum panggil lagi. Siapa? Kang Pelin dah lari dah. Teh Lewai. Teh Lewai. Belum buat lagi. Okay. Cewek, 3,200. Yes, correct. 3,200, betul. Okay. Ada yang tak boleh buat komen Saya tulis jawapan. Number 3. Kalau tak boleh you ni you angkat tangan atau komen. Radioactive material half-life 20 days. Calculate number of days taken for activity to reduce to 25 of its initial activity. Okay, number 3. Tan Jiaying. Number 3, apa answer? Tak ada. Cheng Yuan Z dapat jawapan tak? Forty days. Yes, correct. 40 days. Ada yang tak dapat komen? Okay, number 4. Half-life. Sample Y become 12.5% from its original value after a day. Calculate half-life. Dia dah bagi dah 1 day time taken. Okay, answer apa? Number 4. A day is 24 hours. (12.5%) is 1/8, meaning half to the power 3. N equals to 3. Half-life equals to 24 hours divided by 3. So 8 hours. Okay, so half-life ialah 8 hours. Kalau tak tahu, you comment. Okay, sama je. You all boleh guna teknik ni. Reduce lah sampai 12.5. Okay. Jadi dia akan lalu 3 half-life. 3 half-life ialah 24. So half-life 8 hours. Okay. Alright. Okay, number 5. Element X, half-life 3 years. Okay. Original mass 300. Calculate how much has decayed. Just now we just mentioned what is left. 12.5% left. Now how much decayed? Jadi ada proses lain sikit lah after that. So 300 gram after 12 years, how many half-life? 12 divided by 3 means 4 half-life. Okay, kalau 4 half-life, we need to find what is the mass left. Saya guna formula half for 300. So I will get 300 divided by 16. I will get 18.75 gram. Okay, you can try lah ya. You can try. Betul ke? 4 half-life. Okay, 300 become 150, become 75, become 30, what? 35, 37.5, and then 18.75. 1, 2, 3, 4. 3, 3, 3, 3, 3, 12. Okay. And then this is what left. how much has decayed. How much has decayed means decayed dah yang sudah decay, you kena ambil 300 minus 18.75. You dapat 281.25 gram. Jadi kena baca soalan betul-betul, you faham soalan dia. Sebab formula yang kita calculate ialah yang left, yang not yet decay, not yet decay, belum decay. Ialah kita hanya boleh measure yang ada dekat depan kita je lah, what is left only. The one that gone already, how to get them back, to measure. Okay, so we just can measure what not yet decay. So if the question want you that one that has decayed, so you need to minus lah. Take initial one minus what is left. So that one you get is decayed, yang sudah. Okay, itu half life. Okay, sudah. Kalau ada soalan cepat-cepat tanya, saya laju. Saya nak pergi nuclear energy. Alright, nuclear energy. Now, very important in the process of electricity generation. Kita ada nuclear sector, nuclear reactor. Okay, jadi the process of atomic energy release, ini adalah nuclear energy. During nuclear reaction, kita ada radioactive decay, nuclear fission atau nuclear fusion. Okay, kalau decay tadi pun you dah lihat contoh macam gamma decay. Kalau gamma decay memang energy that release out. So we can calculate the amount of energy released out. The energy that release out, we call it nuclear energy. Okay, let's look at the nuclear reaction. The first one, nuclear fission. Fission ini berkaitan dengan split atau pembelahan. Satu nukleus dia terbelah dua, pecah kepada dua. Okay, nuclear reaction when heavy nucleus splits into two or more lighter nuclei while releasing large amount of energy. Kena memorize. Example, uranium-235 bombarded by single neutron. Satu neutron bombard uranium-235. So dia akan jadi unstable. Dia akan jadi sangat unstable. So bila dia tak stable, dia akan lalu proses yang kita panggilkan sama ada decay ataupun fission. Okay, tengok pada elemen yang terlibat lah. Okay, now dia akan split to two, produce barium, krypton. Okay, ini dia punya nuclear number, barium, krypton. Barium and krypton, if you compare the nuclear number, it is lighter nuclei compared to uranium. That's why dia kata two or more lighter nuclei. At the same time also release neutron, 3 neutron and energy. This is example of nuclear fission. Nuclear fission is very important reaction that apply in the nuclear reactor. Dalam reaktor nuklear nak generate energy, dia gunakan nuclear fission. Okay. As you can see here, one uranium, it release out 3 neutron. Okay. So what happens to the 3 neutron? The possibility is that these 3 neutron will continue to collide with another uranium nucleus. Because not only one uranium inside, and there are maybe millions of uranium atoms inside. So these 3 neutron will continue to collide another 3 uranium and produce the same process. One split will produce another 3 neutron. Here also 3 neutron. Here also 3 neutron. And give out energy, of course. And then the new 3 neutron will continue to collide with another uranium. Mean unstoppable. This action cannot be stopped. Okay, if we didn't control the neutron that release out, means the process will become chain reaction. Okay, macam hydrogen atom. Hydrogen bomb, bomb. Macam bom nuklear. Okay, bom nuklear dia tak boleh control. So lastly dia explode. Large amount of energy. Okay, so this neutron will bombard another uranium nuclei and release more neutrons. Okay, through continuous nuclear fission. Okay, itu ialah proses nuclear reaction. Kalau kita biarkan neutron tu akan terus collide sebab kita ada millions or maybe billions of atoms or nucleus of uranium. Okay, you imagine berapa energy release kalau satu uranium energy dia berapa? If we have billions of uranium atom inside, okay, so it's very dangerous. That's why ada safety precaution. Nanti kita lihat. Okay, next, nuclear fusion. Nuclear fusion is a small and light nuclei fuse. Okay, two or more, okay, lighter nuclei, two or more, sepatutnya lebih, dua atau lebih. Lighter nuclei fuse maksudnya dia join balik, dia combine to form heavier nucleus while releasing large amount of energy. Happens under extremely high temperature and pressure, normally at the surface of sun. Extreme temperature, maybe millions of degrees Celsius. So this nuclear fusion is not suitable to be used in nuclear reactor because they're not extreme temperature. Baru dia boleh releasekan energy tu. Okay. Example, deuterium and tritium. Ini adalah isotopes of hydrogen. You tahu apa tu isotop? Isotope of hydrogen kita ada 3. Hydrogen 1, hydrogen 2 deuterium, hydrogen 3 ialah tritium. Okay. Jadi dia boleh fuse, example, deuterium and tritium fuse or combine to become helium and release one neutron plus energy. Okay, so ini ialah fusion. Fuse, combine, join balik. Two lighter nuclei combine to form heavier nucleus by releasing large amount of energy. Okay, now according to Einstein. Tahu siapa dia Einstein? Saya cuba laju sikit. Einstein. According to Einstein, the process of releasing nuclear energy by process of nuclear process, sama ada decay, fusion atau fission, if you go and calculate the total mass before decay and after decay, the mass are not same. Meaning mass after reaction is smaller than before. Or we can say there is loss of mass. The loss of mass is called mass defect. Sepatutnya mass sama lah sebelum dengan selepas. Tapi bila pergi calculate, menggunakan formula atomic, menggunakan teknik ni gunakan unit untuk unit atomic mass unit yang kecil, 1 AMU. 1 AMU ni sebab mass of an nucleus is too small, that's why they define this ialah 1/12 times mass of C carbon 12. Okay, jadi dia dapat 1.66 times 10 power negative 27 kg. Okay, ini value dia. Okay, nampak tak sini? AMU. Okay. Kalau tak, calculation you akan involve very large value, very small value like negative 27, negative 30. Okay, jadi kita guna itu. Formula, according to Einstein, the mass loss, mana pergi mass defect? Mass defect converts to nuclear energy. Maksudnya, mass yang hilang tu sudah jadi energy. Okay, Jadi formula dia ialah E equals mc squared. C ialah speed of light. Okay, mass defect dalam kilogram, E dalam joule. Okay, example sini. Okay, contoh. Radium 226 decay to become radon 222, emit alpha. Okay, dia akan bagi mass dalam atomic mass unit. Macam ni. Memang agak panjang belakang decimal tu. Okay. Mass of alpha, 1 AMU ialah 1.66 times 10 power negative 27. So what you do, you need to find the mass defect. Totalkan saja radium punya, then equals to mass before ialah radium, mass after ialah radon and helium atau alpha. Okay, jadi you minus, you dapat ada 0.00523. Jangan rounding off, jangan rounding off sini. Okay, sudah dapat AMU, ini dalam AMU, you convert to kilogram. Macam mana convert? Multiply dengan 1.66 times 10 power negative 27. So kita dapat dalam kilogram. Okay, sudah dapat kilogram, barulah ganti dalam formula ni. M dia mesti kilogram. C, speed of light. So your answer will be in joule. Okay. Kalau you nak tukar kepada EV, electron volt, EV pun boleh. Okay, maksudnya you kena dividekan dengan power negative 19 joule. Okay, you akan divide dengan 1.6 times 10 power negative 19. Kalau you nak tukar EV, sebab energy pun boleh bagi dalam EV. Jadi jawapan pun dalam EV. Okay. Boleh juga. Power generated, E divide by T power. Okay. Reaction occurs 10 microsecond. Okay. Jadi you divide lah. Okay. Ini ialah energy. Ini ialah power. Convert to second. Tak mau micro. Micro ialah 10 power negative 6. So you dapat 7.81 times 10 power negative 8 watt. Ini power generated. Okay. Ini contoh soalan. Okay. Calculate mass defect. Okay. Kalau dia dah bagi dah ni energy, terus dia guna E equals to mc squared lah. Maksudnya M ialah E divide by C squared. Jadi 5.4 10 power negative 10 divide by 3 times 10 power 8 squared. Jadi you akan dapat mass dalam kilogram. Okay, mass dalam kilogram. Okay, you akan dapat 6 times 10 power negative 27 kg. Okay, kilogram. Okay, bawah tu you all boleh try. Saya bagi jawapan lah ya, sebab saya nak sambung sikit lagi. Okay, untuk yang E tu, bawah ni number 2 tu, answer you all dalam joule, cuba tukar ke EV. Cuba try tukar ke EV. EV ialah 4.95 10 power 6 EV. Macam saya tunjuk tadi. Macam mana you dapat ni? EV. Ataupun dia jadi 4.95 apa? 10 power 6 ialah mega EV. Okay. Kalau paper 1 tu sometimes saja nak test you all untuk unit juga. Okay, number 3 you pergi kira, you dapat mass dia ialah 2.05 10 power negative 30 kilogram. Okay. Okay, number 4 ini dia dah bagi. Oh, guna cara yang sama tadi Saya bagi final answer saja. E 2.779 10 power negative 11 joule. Okay. Ini dalam joule. Guna cara yang saya tunjuk tadi Kirakan mass before minus mass after, you dapat dalam AMU. Then multiply dengan 1.66 times 10 power negative 27, you dapat dalam kilogram. Then you gunakan formula E equals MC squared. Okay, cuba. Okay, last part, secara laju. Generation of electricity in nuclear reactor. Okay, boleh baca buku teks tentang nuclear reactor. Uranium-235 produce heat energy by undergoing nuclear fission and chain reaction. Okay, water that is pumped into reactor core absorb heat energy. Temperature of water increase until reaches boiling point, meaning water will change to steam at high temperature. Water changes to high pressure steam that will flow through turbine. Okay, the high pressure steam rotates the turbine. The turning of turbine rotates the magnet or coil in the generator by electromagnetic induction, so generate electricity. The steam cools down and condenses into water. Electromagnetic induction occur in generator and produce electrical energy. Electrical energy generated is sent to consumers via power supply transmission system. Ini kita dah belajar juga tentang transmission system. Okay. Untuk structure of reactor nuclear, you boleh lihat buku teks. Okay. Dia ada safety features. Dia punya wall mesti very thick concrete wall. Kenapa? Prevent radioactive radiation leak into surrounding. Kalau you pernah tengok video, you boleh tengok ada yang di Chernobyl tu, reaktor nuklear dia explode. Okay, bahaya kan kalau radiation release to surrounding, kena pada manusia. So dia ada health issue lah. Okay, water as cooling agent, dia mesti ada water. Selalu reaktor nuklear dia build near to the water source. Tepi sungai ke ataupun ada water source yang senang. Absorb heat energy and control reactor nuclear. Juga perlu cooling down sebab temperature sangat tinggi dalam panas. So perlu cool down juga. Okay, to control the chain reaction. Macam mana nak, kalau tak control tadi, energy akan no limit release out. So dia guna apa? Control rod. Control rod ialah boron or cadmium. Apa boron and cadmium buat? Each one of the fission that release 3 neutron, dia akan absorb 2 neutron, for example. Maksudnya absorb excess neutron. Jadi dia boleh control the process. Okay, ini panggil control rod. Moderator untuk apa? Slows down the fast moving neutron. Neutron that released by fission, dia moving very fast sebab dia energy dia tinggi kan. So kita guna moderator which is made of graphite atau water. Dia akan slow down the neutron sebab slow moving neutron only can bombard the uranium. Okay, kalau dia fast moving dia tak boleh nak bombard, mungkin dia pergi tempat lain. Jadi slow moving neutron akan bombard the uranium untuk fission process. So we need to slow down the fast moving neutron. Ini ialah graphite atau water. Jadi kita ada dua jenis control rod dengan moderator. Okay, jadi kena faham function. Okay, untuk management of the waste, you boleh tengok yang high level, bacalah buku teks, high level management, macam mana dia nak manage untuk yang high level waste tu, untuk radioactive waste. Kita ada moderate dengan low level. Ya, ini boleh baca dalam buku teks. Okay, untuk reaction, soalan-soalan berkaitan nuclear reactor tu, yang ni sangat penting lah ni. Control rod, moderator, fission process. Okay, tu semua sangat penting. Okay, boleh baca lagi dalam buku teks. Okay, saya dah habis satu bab nuclear energy. Ada soalan? Any question? Dah habis topik physics nuclear. Boleh faham tak? Okay. Okay, I think that's all. Sudah sampai 6:30. Kalau ada soalan boleh hantar dalam Telegram. Okay. Untuk yang tak hadir tu saya akan share video dia sebab saya dah record dalam Google Meet ni, saya record tapi video dia akan datang lewat sikit lah after one day. Okay. So ada soalan? Kalau ada soalan boleh buka mic tanya ataupun tulis dalam chat. You have anything? Anything that you want to ask for the whole parts of this chapter? Okay, if don't have, then I think I will end our class now. Okay, thank you for joining me today. Okay, bye.